Okay, we'll now look at question 7. Question 7, given this trigo expression here, 3 cosine 2x minus 1, state the least and greatest value. So very simply, the greatest value is simply 3 plus negative 1, which will be equals to 2, whereas the least value is simply equals to negative 3 plus negative 1, which will give me negative 4. Okay, so this is the least and greatest value. Period is simply by, if you recall the formula, period in this case, you can, since question never say degree or radian, I think it's fine to leave in either form. It will be, in this case, 360 degrees divided by 2, which will be equals to 180 degrees. Okay. Then last part, sketch the graph. The information that we have found in part 1 and part 2 will be useful to sketch this graph in part 3. So sketch the graph, first thing, I'll draw the axis first, the y-axis. Okay, then after that, I can now find the axis of the curve, which is negative 1. So if I were to sketch on this graph over here, I'll mark out negative 1. Then I'll mark out the maximum, at the greatest and the least value, which is in this case 2 and negative 4. Okay, then once I've drawn, I can now draw the x-axis, which will be here, which will be somewhere around here. Okay, this is my x-axis. Okay, then from here, I can mark out my x-axis. Then afterwards, I mark out the 0 mark here. Okay, I know that I can draw the middle line for my axis of the curve, which will be here. Okay, then I look at the fx again. Fx is 3 cosine 2x minus 1. This is a positive 3 over here, which means that it follows the very standard shape of a cosine graph, which is something like this. Okay, so therefore, if I were to mark out from 0 to 360, this tells us that since the period is 180 degrees, from 0 to 360 degrees, there are 2 cycles within this range over here. Okay, so therefore I can split very closely. I will split this graph into 2, 180 degrees and 360 degrees. Is it proportionate? 360 degrees. Okay, make sure that use a ruler to make sure that you have split this proportionately. Then after that, within this one cycle, I can split this into 4 parts. So over here, the 4 parts would be 90 degrees. Then after that, each interval will be 45 degrees. Okay, 135 degrees. Then I can do the same thing for the next cycle. Make sure to use a ruler so that the points are evenly distributed. Okay. Then over here I can mark out as well. 270 degrees. 235 degrees. 225 degrees. Each interval is 45 degrees and 315 degrees. Okay, so from here, if I now were to sketch the graph, I know that one period is 180 degrees, and then my cosine graph always starts from the maximum. So it starts over here. It should. So take note, it should cut the axis of the curve at 45 degrees, not the x-axis at 45 degrees. So if I were to draw my dotted lines, okay, it will help me a lot in telling me where exactly should my graph be at different points of the curve. Okay, so over here you can see that. Take note, in this case, if I were to sketch the graph, it will look something like this. It will cut the axis of the curve at 45 degrees. So meaning common mistake here, not the x-axis at 45 degrees, but at 45 degrees, the value of your curve should be at -1. Okay, the value of fx. Then after that, my curve will bend downwards towards 90 degrees, whereby it will be a maximum point here. Okay, then after you'll bend back. So the graph should look something like this. Okay, Yep, so this is one period. I just need to replicate this for the second period, for the second cycle. So in this case, okay, you just need to make sure you use the dotted line to show very clearly to the marker that you know where exactly should the points be at the key parts of this graph. Okay, so I know that the graph should therefore look something like this. Let me continue to extend this from here. It will look something like this. Then you curve down, it will repeat one cycle again. Here we are. It will repeat one cycle again. Remember, it cuts the axis of the curve at 225 degree. Not the x-axis at 225 degree, but the axis of the curve here. Okay, before it bends down again. Then after that, I can connect the remaining parts of the curve. Okay, so this is how we sketch the general cosine function. Okay, my line is not straight because I'm not using a ruler, but by right, you should use a ruler to make sure that the values are aligned. Okay, so therefore, last part is to label the curve. In this case over here, this is the function y, sorry, equals to, over here, y equals to 3 cosine 2x minus 1. Okay, so this is the answer for question 7. Okay, so let's move on now to question 8. Question 8. The equation of a polynomial is given by this expression here. Show that a is equal to negative 9 given that x minus 2 is a factor. So by factor theorem, if x minus 2 is a factor of px, by factor theorem, this means that, okay, p, if I sub x to be equals to 2, I should get 0 if x minus 2 is a factor. So therefore, I can just sub in x equals to 2 into these x values over here. So over here, I will have 2 times 2 cubed plus 2 times 2 square plus a times 2 minus 6 equals to 0. Then from here, you just simply solve for a from here. Okay, over here could be quite simple. 16 plus 8 plus 2a minus 6 equals to 0. You'll be able to solve that. 2a plus 18 equals to 0. A equals to negative 18 divided by 2, negative 9. Yep, sure. Okay, so this is the answer for part A. Let's look at part B now. Hence, solve the cubic equation px equals to 0. So hence means I make use of part A. So over here, since I know that x minus 2 is a factor, okay, therefore I can say that px, which is originally now px equals to 2x cubed plus 2x squared minus 9x minus 6. This can be rewritten as x minus 2 over here. Then after that, times a, no, I already used a already, so I'll use unknown values again. Let's say I use b, c, d. bx squared plus cx plus d. Okay, because I know that x minus 2 is a factor, so therefore I only have the remaining factor over here multiplied to x minus 2 must be a quadratic factor in order to obtain a power 3 over here. Okay, but I don't know what are these values of b, c, and d. So how to do that? I can simply use comparing coefficients to find out the values of b, c, and d. So by comparing coefficients, okay, if I compare, let's look at the value of b first. To obtain a b is simply, we know that x multiplied to bx squared will give me 2x cubed. So therefore, this tells me that straight away, b is equal to 2. Okay, next one, I know that it's harder to find this c over here, so I can find what is d over here first. D is a constant. Negative 2 times d will give me negative 6 over here. So therefore, I can write it as such. Negative 2 times d will give me negative 6. D will be equals to 3. Okay, so therefore over here, and I know I have found the value of b and d. My last one is to find the value of c. Okay, so over here, I can simply rewrite this to become, let's say from here, I want to find the value of c. Let's try to compare x square terms then. I know that from here, comparing coefficient x times cx will give me an x square term. Negative 2 times bx will also give me an x square term. So therefore, cx square minus 2bx square, and this should give me the x square term over here, which is 2x square. Okay, and I know the values of b. B is 2, so therefore cx square minus 4x square is equal to 2x square. So therefore, by comparing coefficients, we know that c minus 4 must be equal to 2. Equals to 2, therefore c is equal to 6. Okay, so therefore, from here I can therefore conclude that hence px can be rewritten as x minus 2 times b is 2x square plus 6x plus 3. Okay, then my last step now is that I want to solve for this equation. So since solve the cubic equation px equal to 0, so therefore what I would do from here is that when x minus 2, 2x square plus 6x plus 3 equals to 0, therefore this tells me that x equals to 2, or 2x square plus 6x plus 3 equals to 0. So I have a quadratic equation over here. Recall, to solve any quadratic equation, you can either factorize them or use the quadratic formula or completing a square. In this case over here, since these are not factorizable into nice linear factors, the easiest way in this case will be to use my quadratic equation or quadratic formula to obtain the solutions of this quadratic equation. So x is simply negative 6 plus minus b square minus 4ac, which is 6 square, minus 4 times 2 times 3 over 2 times 2. Okay, and you will get two solutions. The question say express non-integer roots in surd form, meaning that I should simplify this in order to get my answer as a surd. So therefore, if I simplify this from here, it will be negative 6 plus minus square root 6 square minus 6, which will be 36, minus away 24 over 4. So from here, if I simplify this further, negative 6 plus minus square root 12 over 4. Then from here, I can continue to simplify. Root 12 can be simplified further into negative 6 plus minus 2 root 3, okay, over 4. Okay, so therefore my final answer, if I simplify this even further, it will become negative 6 plus minus root, I divide the whole thing by 2, so this will become negative 3 plus minus square root 3 over 2. And this is my final answer, whereby x is either equals to 2 or these two roots over here. Okay, so this is my final answer to question 8. Alright, so now let's move on to question 9. Question 9, prove that this is a proving question. By observation, I can see that the left-hand side does seem to be easier to solve than the right-hand side. So I'll simply simplify the left-hand. I'll start from the left-hand side here. LHS equals to cosine B over 2 cosine A plus sine B over 2 sine A. So intuitively, what we would do is to combine these two fractions into one single fraction. We notice that the denominators are not the same. So what I'll do is I'll make the denominators the same by multiplying sine A to this entire fraction and multiplying cosine A over cosine A to this entire fraction. So what we will get would be sine A cosine B over 2 sine A cosine B plus cosine A sine B over 2 sine A cosine A. Sorry, did I write only? Cosine, this one should be cosine A. Okay, then from here, we can combine them into one single fraction. Sine A cosine B plus cosine A sine B over 2 sine A cosine A. And by observation, you should be able to see that my numerator is actually my sine addition formula. And this can be simplified to become simply sine A plus B. Okay, whereas my denominator can be, using my sine double angle formula, can be rewritten as sine 2A. Okay, then from here you can see that this can be written as 1 over sine 2A times sine A plus B over 1. Okay, so if I want to observe, right, what I want to get is a cosecant, 2A and cosecant A plus B. Okay, so from here we can see that this can be rewritten as 1 over sine 2A is simply cosecant 2A. Then over here, if I want to turn into cosecant, my sine needs to be in the denominator. So I can just turn this into a divide sign. Divide by 1 over sine A plus B. Okay, then from here we can see that this is simply cosecant 2A divided by cosecant A plus B, and therefore I will get cosecant 2A over cosecant A plus B. Okay, and therefore I've obtained the identity which I want to show on the right hand side. So therefore it's important to end off my proving question, which is equal to RHS, and therefore from here I've proven the required identity. Okay, so this is for question 9. Okay, moving on to question 10. Question 10, express the following in partial fractions. So remember, the first step to solve any partial fraction question is to first identify, is it an improper or proper fraction? I can do so by identifying the degree. My numerator, the degree is 3. My denominator, the highest degree of x, is also 3, because if I expand this to linear factors, linear and quadratic factor, x times x will give me x cubed. So therefore, this is a improper fraction. Okay, so in order to do partial fractions, the fraction must be proper first. So when I see an improper fraction, my first step is to use long division. So over here, I'll divide my numerator by the denominator over here. So my denominator, x minus 2 times x squared plus 1, I can expand first. So I'll get x cubed plus x minus 2x squared minus 2. Okay, so therefore if I were to use long division, okay, I can see this as x cubed minus 2x squared plus x minus 2. This is my divisor. I'm dividing 2x cubed plus 2x minus 5 by this divisor over here. Okay, so over here is simply doing a long division. I'll get 2, so therefore 2x cubed minus 4x squared plus 2x minus away 4. Okay, it's easier to shift my terms here, so I can see this much clearly from here. Okay, so therefore, if I were to simplify this even further, I will get a remainder of 4x squared plus minus 1. Okay, 4x squared minus 1. So therefore, now that I've done my long division, I can now rewrite this original fraction. Original fraction here can be rewritten as therefore 2x cubed plus 2x minus 5 over x minus 2 x squared plus 1 can be rewritten as, in this case over here, 2 plus the remainder over divisor, which is 4x squared minus 1 over this divisor here, which is x minus 2 x squared plus 1. Okay, if you have forgotten how come we can write in this form over here, you need to go and check back on your notes. Okay, then after that, from here, I check this fraction now. This fraction, is this now a proper fraction? Check the degree of the numerator, 2. degree of the denominator is x times x squared, which is 3. So therefore, degree of the numerator is less than the degree of the denominator, so it is a proper fraction. And then we can now do our partial fraction decomposition. This is a proper fraction. Okay, so from here, what I can do next, simply let 4x squared minus 1 over x minus 2 times x squared plus 1 be equals to, then I check my denominator factors, linear factor and irreducible quadratic factor. This can be written as a over x minus 2 plus bx plus c over x squared plus 1. Okay, where a, b, c are arbitrary constants. Okay, then from here we can just do our standard solving of this partial fractions by first rewriting this as an equation. So therefore, I'll get 4x squared minus 1 equals to a x squared plus 1 plus bx plus c times x minus 2. Then I just choose in values of x that will help me obtain the values of a, b, and c. So first one, I will choose x equals to 2. X equals to 2. This whole factor over here will disappear because 2 minus 2 is 0. So I'll get left hand side will be 4 times 2 square. 2 square minus 1 equals to 5a. So therefore, 5a equals to 15. A equals to 5. Okay. Next one. When I will choose x to be equals to 0 and to get rid of b now. So when x equals to 0, negative 1 equals to this will be 1a. So since a is 5, it's simply 5 plus c times negative 2. Okay, so over here, I'll get 2c equals to 6. 2c equals to 6, therefore, c equals to 3. Did I calculate correctly? A equals to 5. Sorry. I realized that this one should be 3. 5a equals to 15, a equals to 3. So therefore, over here, this is negative 1 equals to 3 plus c times negative 2. Therefore, this will be 4 and 2. Yep, so therefore, c equals to 2. And the last one, to find the value of b, you can just choose any value of x. So let's say I choose when x equals to 1. Left hand side, 4 minus 1 is 3 equals to 2 times a, which is 3, plus b plus 2 times negative 1. So therefore, if I continue to simplify from here, I will get 3 equals to 6 minus b minus 2. Simply b equals to 6 minus 2, 4 minus 3, 1. Okay, therefore, I have found my constants of a, b, and c. I can now answer the question with my final statement. Therefore, 2x cubed plus 2x minus 5 over x minus 2 times x squared plus 1 is equals to 2 plus, and this partial fraction here, I have found it in this form over here. A is simply 3 over x minus 2 plus bx plus c, which is x plus 2 over x squared plus 1. And that is my final answer to this question. Okay, so with that, this is the end of question 10.